Hello everyone. This is in continuation to our hypothesis testing. This is our next problem. A hospital uses large quantities of packaged doses of a particular drug. The individual dose of this drug is 100 cc. The action of the drug is such that the body will harmlessly pass off excessive doses. On the other hand, insufficient doses do not produce the desired medical effect and they interfere with patient treatment. The hospital purchased this drug from the same manufacturer for several years and knows that the population standard deviation is 2 cc. The hospital inspects 50 doses of this drug at random from a very large shipment and find the mean of these doses to be 99.75 cc. Test whether the doses of this shipment are too small. Use zero point 0.1 significance level, means 10% significance level. So first of all, let us capture what are all given in the question. One is the individual dose of the drug is 100 cc. Okay. Then it says the population standard deviation is 2 cc. The hospital inspects 50 doses of this drug and found the mean, that sample's mean is 99.75 cc. And then test whether the doses in the shipment are too small. Use 0.1 significance level. Now, whatever we just captured, we will write it in terms of notation. So first we will say let mu is equal to population mean. What is that? Population mean dosage, I can say dosage in cc is, that is known to be 100. Okay, or assumed to be 100. Okay, then population standard deviation. So I'll use the notation sigma population standard deviation of dosage in cc is given in the question as 2 cc. Okay, the hospital inspects 50 doses, means the sample size denoted by smaller n is known to be 50. Then sample mean is known to be 99.75 or calculated to be 99.75. Sample mean denoted by x bar it is 99.75. This is also in cc. Okay. The level of significance denoted by alpha significance level is given as 0.1 or 10%. So these are the things given. Now, after capturing, the next step is to identify what is this test concerning. So the population parameter here is because the question talks about test whether the doses in this shipment are too small. They are talking about the mean dosage. So the above is a test concerning with it is talking about a single population. So single population mean. Then further, population standard deviation is known and sample size is large. Why? Because n, which is 50, is larger than 30. Okay. So once these things are satisfied, we will say, hence we will use Z-test. The next step is to freeze on the hypothesis, null hypothesis, and then the alternative hypothesis. Null hypothesis, here itself we are clear, mu, we are going to test about population mean. Population mean is known to be 100. So mu equal to 100. Then here it says test whether the dosages in this shipment are too small. Means we are supposed to test whether mu is lesser than 100 or not. So it becomes a one-tailed test. Then the next step is to write down the test statistic. The relevant Z-test statistic will be, let me say, Z-cal under modulus, which is Z calculated value that will be x bar minus mu divided by SE, where SE is the standard error. Standard error will be sigma by root of n. Sigma is known to be 2 and root n means root 50. Root of 50. So let's calculate this. So it is 2 divided by 7.07. So that will work out to 0.283 approximately. Therefore, Z-cal under modulus will be modulus of x bar. X bar is known to be 99.75. Mu is known to be 100. And this standard error is 0.283. Now let us calculate this. 99.75 minus 100 divided by 0.283. So that works out to 0.883. The next step is to write down Z tab, that is Z table value for a one-tailed test. One-tailed test at 10% level of significance within modulus, and that value from the tables will be 1.28. Now we can infer now. So the inference, since Z-cal, which is what it is, 0.883, is lesser than Z-tab, which is 1.28, we accept null hypothesis. That will be the conclusion. Means I can conclude that the population mean can be accepted, or there is no reason for rejecting that the population mean is not 100. So it can be accepted. That will be the conclusion here. In case if you find the contents of this video to be useful to you, I please request you to like, share it with your friends, and also subscribe to my